Hello, welcome to Astronautics for Exploit. This is Dr. Anyashola Ogundele. Lunar High-Tech Space Railway System, a space migration plan infrastructure for making human settlement a possibility. The focus points as follows: space migration infrastructure, Lunar High-Tech Space Railway System, development of Lunar Space Railway System via in-situ resource utilization, and Lunar Space Railway System concepts. Space transportation system, essential for the transportation of materials and humans from Earth to spacecraft orbit, spacecraft orbit to Earth, spacecraft orbit to spacecraft orbit, planet to planet, star to star, and galaxy to galaxy is gradually becoming a necessity based on the increase in deep space missions and humans' interest in space voyage for tourism, businesses, and research activities. Presently, one of the space transportation systems being of great interest to the government, space agencies, private space companies, and investors is the design, development, and building of Lunar High-Tech Space Railway train system for the benefit of humankind. Examples of various agencies and companies embarking on revolutionizing access to space and lunar space railway strategies are NASA, JAXA, DARPA, Northrop Grumman, Space Railway Company, and a host of others. The idea is to prepare ways for mining water ice, nuclear power plants, and factories. Presently, several lunar high-tech space railway systems concepts are being developed. Examples are flexible levitation on a track concept, Japan interplanetary trains concept. To achieve human settlement and easy mobility of machines on the lunar surface, Northrop Grumman is developing interfaces and resources necessary for building a lunar railway network, and the host and many more. Flexible levitation on a track concept is being designed to transport payloads of varying shape, of up to 110 tons in weight, from landing zones to permanent outposts. According to the design, float robots will have no moving parts and will levitate over the track in order to minimize lunar dust abrasion or wear, unlike lunar robots with wheels, legs, or tracks. Space migration infrastructure. Human migration to outer space and space exploration that was once scientific endeavors and sci-fi are now becoming a reality. Presently, space migration is seen as potential catalyst for achieving the United Nations Sustainable Development Goals. Venturing beyond planet Earth will contribute to sustainable development on the Earth. Artistic depiction of a lunar base is shown in this picture. Based on the limited and diminishing resources of minerals and critical raw materials on the Earth, humans presently are looking to space, the Moon, Mars, comets, and asteroids for new supplies. Space exploration and mining require space infrastructures in order to establish off-Earth manufacturing in space. This thereby necessitates the need to develop highly efficient space infrastructure. Illustration of mining on the Moon using in-situ resource utilization approach is shown in this picture. Lunar High-Tech Space Railway System. Presently, efforts are in top gear to build Moon High-Tech Lunar Railway System, which will provide reliable, autonomous, and efficient payload transport on the Moon. Various government space agencies and private space industries are investing into the design and build of the high-tech trains network on the Moon in order to enable effective transportation over the lunar surface. Illustration of high-tech space railway system on the Moon is shown in this picture. The lunar landings a series of Artemis missions returning personnel to the moon in 2028, and the proposed high-tech train are pivotal to NASA's Gateway project, a lunar orbiting space station that will serve as a hub for fast planetary exploration, especially for the Mars. Leveraging advanced robotics and expertise in system integration and autonomous services, Northrop Grumman aims to pioneer the train infrastructure which is needed for future lunar exploration and commercialization. Illustration of proposed high-tech train on the moon is shown in this picture. Development of lunar space railway system via in-situ resource utilization. In-situ resource utilization is the practice of collection, processing, storing, and the use of materials found or manufactured on other astronomical objects that replace materials originated from the Earth. According to the research findings, in-situ resource utilization can provide materials, including water, rocket propellant, and construction materials. Illustration of ISRU technology on construction and the moon is shown in this picture. Efforts are underway to build a multi-purpose in-situ resource utilization based lunar construction systems on the moon. This will help in using lunar resources to construct the proposed moon high-tech railway system. The use of in-situ resources for the construction of the train system is being proposed because it is not feasible to send traditional Earth-based construction equipment and materials to the moon. An artist rendering of astronauts working near NASA's Artemis base camp, completing with a rover and RV, is shown in this picture. Lunar high-tech space railway system concepts. Several lunar high-tech railway train stations are presently being developed and proposed. Examples are flexible levitation on a track concept, Japan interplanetary trains concept, and DARPA lunar railroad concept. An artist's impression of the Voyage 1 space probe flying past Saturn in the outer solar system is shown in this picture. Flexible levitation on a track concept is being designed to transport payloads of varying shape, up to 110 tons in weight, primarily from landing zones to more permanent outpost settings using the proposed high-tech railway station. The train is aimed for machines only. A durable long-life robotic transport system critical to the daily operations of a sustainable lunar base by 2030 is under development. Artist's depiction of the float lunar railway system, which is being designed to provide reliable, autonomous, and efficient payload transport on the moon, is shown in this picture. The robotic transport system will use unpowered magnetically polarized robots in order to levitate above a three-layer track made of flexible films. Float robots have no moving parts and then levitate over the track. Illustration of train on the moon for easy vehicles and human movement is shown in this picture. Float is designed to operate autonomously in the dusty, inhospitable lunar environment with minimal site preparation. Unlike roads or railways on the Earth, float tracks have the ability to unroll themselves in order to avoid any other major construction projects happening on the surface. The network of tracks can be rolled up or it can be wiggled over time in order to match evolving lunar-based mission requirements. A revolutionary lunar railroad system is shown in this picture. Flexible levitation on a track concepts major tasks as follows. Define mission requirements: the payload, mass, size, quantity, transport distance, power, and a host of others. Simulations of flow system with middle-scale robots. Experiment on existing centimeter scale float-like robots to study the most pressing questions, and size float system to match mission requirements using predicted lunar performance from simulations, and experiments. An artist's illustration of what manning on the moon might look like is shown in this picture. The Japanese interplanetary trains concept is another high-tech space railway system under proposition. It is being proposed for an interplanetary transportation system, referred to as S-track, that maintains a gravity of 1G during long-distance travel in order to mitigate the effects of prolonged exposure to low gravity. The S-track trains will possess exocapsules, which are essentially hexagon-shaped capsules with a moving device in the middle. An example of moon-based infrastructure, a lunar railroad, which could connect different outposts on the moon, is shown in this picture. A mini capsule with a radius of 15 meters will connect the Earth and Moon, according to the ESA-track mini capsule proposal, and the larger capsule with a 30-meter radius will connect the Moon and Mars. According to the design, the EARTH capsule will use electromagnetic technology that the magnet trains and employ in order to stay afloat. Construction of railway on Moon for future human habitation is shown in this picture. The DARPA Lunar Railroad concept is another lunar high-tech space railway system concept under design and consideration. DARPA picked Northrop Grumman in order to develop lunar railroad concept. The railroad will open the moon to sustain economic development. The envisioned lunar railroad network could transport immense supplies and resources for commercial ventures across the lunar surface, contributing to the space economy. Illustration of levitating robots railway on the moon is shown in this picture. Northrop Grumman Lunar Railroad investigation outline are as follows. Define the interfaces and resources required to build a lunar rail network. Establish a critical list of foreseeable costs, technological and logistical risks. Identify prototypes, demonstrations, and analysis of a fully operating lunar rail systems concept design and architecture. Explore concepts for constructing and operating the system with robotics, including grading and foundation preparation. Plan of futuristic moon train to revolutionize lunar transportation is shown in this picture. For more information, contact Astronautic for Exploits. You've been listening to Lunar High-Tech Space Railway System, a space migration plan infrastructure for making human settlement a possibility, presented by Dr. Ayenshola Ogundele, with the focus points: space migration infrastructure, Lunar High-Tech Space Railway System, development of Lunar Space Railway System via in-situ resource utilization, and Lunar Space Railway System concepts. Thank you.